In this section, we're going to look at fractions, and most specifically, how to add, subtract, multiply, and divide fractions. A few vocabulary terms that we need to look at before we start getting into the actual lesson are, you're going to hear me say numerator. And if you do not know what that is, a numerator is the top number in the fraction. So when you hear me say numerator, just remember that's talking about the top number. The bottom number is called the denominator. So anytime we talk about the denominator, we're talking about the bottom number of the fraction. You'll hear me say those two a lot. Also, we'll talk about the least common multiple, or abbreviated LCM, and that is just a number that two other numbers can multiply to equal, and it's the smallest number that those two numbers can multiply to equal. For example, the least common multiple of 2 and 3 would be 6, because 2 times 3 is 6 and 3 times 2 is 6. So looking at adding fractions, I want to think about this visually so you can conceptualize maybe what we're actually doing with adding fractions and why we do it the way we do. If I were to add 5/6 and 1/4, we can see the visual representation down here at the bottom. But if I tried to add these two things together, I don't really know how to write that number because the pink section is larger than these blue sections. I can't combine them the way that they are because the sections are not the same size, they're not equal size. So we have to do something to make sure that when we count our sections, they're all the same size. And we do this by finding the least common multiple of the denominators, 6 and 4. So we got to think of a number that we can multiply times 6 and that would equal something, and something we can multiply times 4 to equal that same number. If you'll start with the larger number, so start with a 6, and think of all the multiples of 6. 6 times 1, that's obviously 6. 4 cannot multiply by anything to equal 6. 6 times 2 is 12. Well, 4 can multiply by 3 to equal 12. So 12 is going to be our least common multiple. So before we actually look at the calculation, let's think about it visually. If I'm looking at my top one where I have 5/6, I want to change this into 12 equal sections. I can do this by separating each of the sixth into 2 equal parts, because 2 times 6 is 12. So we can separate each of those into equal parts. And now you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 twelfths. So 5/6 is the same as 10 twelfths. 10 twelfths. Okay? Or you know that 6 times 2 equals 12, and 5 times 2 equals 10, which is really what we're doing calculations-wise, but you can see it now visually. If I wanted to separate the fourths into equal parts, I would have to separate each of those into 3 equal parts, because 3 times 4 equals 12. So I could separate each of my fourths into 3 equal parts. 1, 2, 3. 1, 2, 3. And now notice that both of my wholes are separated into 12 equal parts. So when I count my shaded areas, for my fourth, there's 3 twelfths. 3 twelfths. So the 1/4 has turned into 3 twelfths. You could also just multiply 4 times 3 to equal 12. 1 times 3 to equal 3. And now we're just going to add those together. Well, obviously, when you look at your shaded areas, we have 10 shaded areas on top, plus another one here. It's 11, 12, 13. So we have 13 out of 12. So 5/6 plus 1/4 is 13 twelfths. You don't have to draw this visual representation, but I want you to think about it in your head on why we have to find a common denominator when we're adding and subtracting fractions. So to add or subtract fractions, we must first find the LCM of the denominators. And this is following right along with your notes. Find the least common multiple of your denominators. Then we will multiply both the numerator, I'll abbreviate that, and denominators. So they have common denominators. And again, remember that when we multiply, we have to multiply. If I multiply the 6 times 2 to equal 12, I have to multiply the 5 times 2 to equal 10. We multiply the numerator and the denominator by the same number. And the last thing we do is we are going to add or subtract, depending on what the operation is. Subtraction works the same way. Add or subtract the numerators only. The numerators only. We don't change the denominators because the equal parts did not change. We still had 12 equal parts in each of our wholes. So the denominator does not change, only the numerator. There's a couple of practice problems below if you want to try those. Pause the video and try those out before we move on to multiplication. Okay, looking at multiplying fractions. I want to look at this visually as well so you can think of it whenever you have any sort of multiplication for fractions. So if we had 2/3 times 4/5, well, I'm going to shade in 4/5 of our whole that we have here. So that would be 1/5, 2/5, 3/5, and 4/5. Okay? And if we're multiplying our 4/5 times 2/3, essentially we want to find 2/3 of this 4/5. So we could separate these fifths into 3 parts. 1, 2, and 3. And now I only want to think of 2 of those 3 parts for each of the shaded areas. And maybe to be more clear, let me show you visually. We only want this first section and this second section of that 4/5. And we're going to do that for each of the fifths that are shaded. So here we have each of our fifths. Each of our 1/5, the 2/3 of it is shaded, and we're only shading 4 of the 5/5. So if we think about how much of our whole we actually have shaded now, by both of them, we have 1, 2, 3, 4, 5, 6, 7, and 8. 8 pieces are shaded by both. Out of how many total do we actually have? We have those 8 plus 9, 10, 11, 12, 13, 14, 15 pieces. So 8 out of 15. Now multiplication is a lot easier because you can notice that 4 times 2 equals 8, 3 times 5 equals 15. We just have to multiply across the top and multiply across the bottom. Also remember to simplify this fraction if you can. This one cannot be simplified. I can't divide both of those numbers by anything, so 8/15 would be my final answer. So to multiply fractions, we must, 1, multiply straight across. It's really easy. Multiplication works really easy for a lot of things. So multiply straight across. And then our last step would be to simplify if possible. Simplify if possible. Sometimes it's impossible like the last one, but just remember that if you had something like 6/8, I can divide both of those by 2, and that would equal 3/4. So make sure that you simplify it if you can. Okay, and lastly, we're going to look at dividing fractions. So for dividing fractions, we will need to remember the KCFM. Just remember that little acronym there, KCFM. So KCFM, or even just the KCF is the big part. K stands for keep. C stands for change. F stands for flip. And the M stands for multiply. Because we're going to change this division into a multiplication. We just saw that multiplication is really easy with fractions, so we want to change this division problem into a multiplication problem. So following this KCFM, it's going to represent each piece of our fraction. The first fraction, the operation symbol, then the second fraction, and then tells us what to do. So the first fraction we are going to keep. 4/7. We don't change that. Then the operation, we are going to change that into multiplication. It's hard to draw the multiplication here. And then the second fraction we're going to flip. We're going to flip that into 3 seconds. Just flip it upside down. And now, since we've realized that multiplication is really easy, all we have to do is multiply straight across. 4 times 3 is 12. 7 times 2 is 14. And in this case, this is one where we can divide both of them by the same number. I can divide each of these by 2 to simplify. 12 divided by 2 is 6. 14 divided by 2 is 7. And that is as simple as we can make that fraction. So 4/7 divided by 2/3 is 6/7. Please make sure that you followed along in your notes and that you have these completed. If you have any questions, make sure you write them on your notes, and we will address those in class.